assuming. Welcome to our talk, Protecting PII, Personally Identifiable Information in Data Lake. I'm Kayuri Shah. I have been in industry for over 15 years as a software engineer, and I accompanied by my colleague Chandi.
Thank you, Kayuri. Thank you, Kayuri. Hope everyone is enjoying their time in Spark Summit. I'm Chandi Chintalapati. I'm working as a senior software engineer in Northwestern Mutual with over 17 years experience building enterprise level applications.
Okay, so before we start, I was thinking I'll open up with a COVID joke or a work from home joke or virtual joke, but I think you guys have heard it all. And you guys might hear it over the course of summit, so I'm not gonna go there. Before we start our talk, I wanted to take 2 quick minutes and introduce Northwestern Mutual. What do we do at our company? So Northwestern Mutual is a financial services company with a revenue of over $31 billion, and it serves 4.6 million clients. It's 102 Fortune 500 company, and we have approximately 11,000 financial professionals now all over the country, and we are headquartered in Milwaukee, Wisconsin. Next slide, Chandi. So we have been, our 4 main pillars have been commitment to mutuality. We are not a shareholder company. We are more committed to our mutuality. Our biggest asset is our financial strength. So only 2 companies have rated highest in the financial strength. One is Northwestern Mutual and another is Microsoft. We have exclusive career distribution over the country. Like you guys saw, we have 11,000 financial representatives, and we believe in giving long-term product value. Next slide. So let's quickly go through our agenda, what we are going to do here. I'll go through what is PII, why do we need to protect it, why it's important, why we are here. And then Chandi is going to go through what is our approach design, what did we do to protect our PII information in Data Lake. We'll wrap it up by showing you quick trade-offs on what we found while adding this column level encryption, and few tips and tricks and what's coming next to us. If time permits, I actually have a bonus slide, and if time doesn't permit, you guys can watch it at the end. It's about how we took the PII information, fabricated it, and put it into non-prod environment to build a non-prod-like environment. It sort of goes in how we did the setup. So let's get started. What is PII? If you guys don't know, personally identifiable information, it can be anything that can be traced to you as a specific individual. So name, date of birth, social security number, all that is what identifies you as a person. I could be called as Elon Musk, doesn't mean I can have Elon Musk bank accounts or credit cards, but if I have Elon Musk's social security number, I could be Elon Musk and have his bank accounts and credit card information, right? So it's very important, and especially for financial industry, when we have access to all of our 4.6 million clients, we store their bank account numbers, we store their credit card information, we store their social security numbers, all sorts of PII. It's at Northwestern Mutual, we treat security as a first-class citizen. So it's equally important to protect their data. They put their trust in us and give us the data. So we want to protect them, and we are protecting them not just from external hackers, but internal employees, admins, everybody who has access to the data. What happens when companies fail to protect data? Well, so big deal, right? You got access to my social security number. What worse can happen? Well, what worse can happen is you can have legal consequences. Almost every other day, if you guys have credit cards, you would get emails saying your information was hacked and we give you 12 years of credit monitoring. Well, all that happens when the accounts or information is compromised, right? We could have legal consequences. There is a big cost to redemption because once it's hacked, it's hacked. There is no going back. There is no protecting once it's hacked. And there are fines, there are settlements, there's lot, and most important, it's the loss of trust that the clients gives. Once they know that the company that they are trusting, they cannot handle their important data, they lose the trust. which is the biggest financial blocker to any financial services in industry. Next. So how can a company lose data, right? How can you possibly lose a data that you have access to? Well, hacking, obviously we have billion hackers around the world and they can come and hack your data, but well, we use AWS technologies, we use S3, we are secure, we use finest things in the market. Social engineering, somebody just posts something, hey, I'm going on a vacation. Well, now they know you are not at home, right? You post images which are marked with your location. All that hackers use to hack your data. Malware, you click on a phishing email, it opens up a link which installs a software on your system and corrupts the whole system. Human error, obviously, I am printing a list of all my clients with social security number, date of birth, addresses, because I want to mark them, and then I just leave it at my desk or at my home for somebody to take it. Well, it's not intentional, but it can still cause hacking. And then insider attacks. Employee goes rogue who had access to all the data, and they just take the data with them, which basically costs millions of dollars. Your data can be hacked using any and more of these ways. So some quick statistics. And just because we all are cloud-centric now, we all want to be on the most modern technologies, most modern platforms, we are just prone to more data breaches. Doesn't mean we shouldn't go on the cloud, but it means we should be more sensible and more proactively protect our data. Almost on an average, if you have a data breach on PII information, it could cost you $3.86 million. And in financial industry, it's actually more because of all the sensitive information they have. And 80% of the data breaches at this point in time currently includes PII information, which means any way you give out your social security number, it's prone to be hacked or it's prone to go out in one way or the other. And the most important statistics that I want to say is it takes 280 days to identify a breach. So let's say your data got breached today, you wouldn't know until a year that it was breached. And what happens in that long duration? Potentially anybody or everybody can have access to the data, right? And that's basically what causes identity thefts these days. So talking about data breach, go to the next slide. Well, these are the recent data breaches and there are more. Every day I hear some company faced a data breach, some company had data issues, lost social security numbers, and things like that. These are the major ones that I could get from internet for last year. But as you can see, we have huge issue with data breaches. So what we try to do at Northwestern Mutual, we want to protect all the PII information. And by protecting PII, we obviously do three things. Column in transit, encryption in transit, which means when your data is being transferred from one place to another, from on-prem to cloud, between databases, between data lakes, between applications, we have to do encryption in transit. And encryption at rest. What that means is when your data is at storage, it has to be encrypted. Some of these things comes by the native technology we use, like using S3, you can get encryption at rest. But in addition to it, what we do is column level encryption. And that's what we are here to talk today. How we do column level encryption, what we do are the details that Chandi can go in. But what basically means by column level encryption is even while data is in your S3 buckets, it's at storage, somebody can access to your files, your social security number is never stored as a plain text in your S3 files. Your names, your birth dates are never stored as a plain text. Anywhere that it goes, it encrypts the data and then stores it, right? So that's what we want to talk about today. Over to you, Chandi.
Here are the steps we follow to do column level encryption. The first step is to identify the PII or PHI columns. So it's hard to identify the PII data. We mostly rely on the developers to identify the PII information rather than the system identifying it. And then in Northwestern Mutual, we developed a framework which works similar to Flyway, which creates these delta tables automatically and then sets these encrypt columns using the table properties. So we have an easy to use config-driven approach which we use, and we create all these delta tables. And then we have our ELT framework, which performs these column level encryption by looking at the table properties based on what we define. So we have both deterministic and non-deterministic. For deterministic, we use AES, and for non-deterministic, we use Fernet. And we define all these columns based on the criteria in the table properties. And then finally, we also created these UDF, decrypt UDF, which basically with some of the users who have these access to view the clear text data, they go and view the clear text data. All other users, they will view the encrypted text.
So one important thing to note here, right? Everybody can have access to social security number, but in an encrypted mode, which means they see junk data, whether they are admins, they are cloud admins, they are S3 admins, anybody who can download files, internal hackers, external hackers, everybody has access to the social security numbers in an encrypted format. We have to do special things to decrypt the data and then give out the data, right? Which is a different mentality than putting masking on. With masking, at rest it's a plain storage, but at runtime, it's encrypted. This is the other way around. At rest, it's encrypted, but you can decrypt the data at runtime. So that's the change in mindset that we are bringing.
Okay, so this is our architecture. So our source data comes from multiple source systems in different formats like relational DB, structured and unstructured files. The first step that we do is we identify the PII and PHI data, and then we create these delta tables and set these table properties for all these PII and PHI columns. And we use, like I said before, Fernet for non-deterministic and AES for deterministic. We use key ECLs to manage who has access to those Databricks secrets. And then our AELT framework loads the source data and encrypts based on the table properties into all these different layers like bronze, silver, and gold. And then the decrypt UDF, the users come in, use Spark SQL, use this decrypt UDF, and then view the clear text data. And for users who don't have access, they just view the encrypted data. And all this access, we drive it through our metadata framework. And there is a blog here. Please refer to this blog for more details on how we implemented and the actual code.
So the blog has all the details with how we have encrypted the data, the actual code, what you can take by yourself at home and encrypt the data. It also has the UDF code to decrypt the data, so you can implement it in your data lake and start protecting your information too.
Okay. So when we started implementing this column level encryption, people started asking us, okay, what would be the bottleneck, or what are we compromising on? So as we are like adding, when we look at, we tested with a file which has 150 million records with 2 columns identified as PII. And when we actually loaded with column and without column encryption, what we noticed is from ingestion perspective, it took 9.62 minutes with column level encryption and 5.37 minutes with no column level encryption. And also in the consumption wise, we have not noticed any much difference. But for the storage perspective, like we noticed, like with column level encryption, it took around 7.4 GB for loading those 150 million records. And without column level encryption, it took like around 7.3 GB.
Okay, so that's all about how we actually implemented it, and you guys can have all the implementation details in the blog to take home, copy it as a notebook that you can use. But I want to go through a few tips and tricks that we have learned in our journey of adding the column level encryption. Well, first thing is, how do you identify what's PII? right? There are various AI algorithms that you can run through, but again, we have a lot of legacy tables where something is called as FST underscore name, and some places it's called first underscore name. So how would AI know? We actually rely on our developers to identify them. When they are doing their development, they go ahead and identify them, and we set them as a table properties. So you could do describe extended on a table, and then see here are all the columns that we identify as PII. It's a neat way, and it's worked out for us, because then you can use that in your ETL logic to say, to describe extended, get me the column names and apply encryption on top of that. And you can integrate that with Collibra or any governance tool you have, and it would flow all the way to say, here are all the PII information. So that's how we started identifying PII information in our data lake. Now, one thing we caught this during our development is, well, you are doing your bronze, you have encrypted your data, put it in your storage. Now you are trying to join two columns, which is fine. They are all strings. You can do a joins on them, but your output is again an encrypted value. Now, when you would run through that your framework or your load, it's going to double encrypted. How does it know that this is an encrypted value? So a neat trick that we applied is we append pipes, which is sort of silly solution, but it works, saying we append pipes to the end and pipes to the start. So then our ELT tool, it looks at and says, oh, you have pipes on both the sides, so it means I don't need to re-encrypt it, just push this data as how it is. That's to avoid double, triple, 4 times encryption that you would have to apply, which means then when I'm decrypting, I have full confidence saying I'm just going to decrypt one single value that I need to go through. UDF function, so when we started this 2 years ago, we had to create a Scala UDF. So we could use it in our SQLs, we could use it in our views, and views are what we give out to our consumers. Now I know you have a way to create Python UDFs, and you can also create SQL UDFs that you could use. Very recently, and we haven't implemented this, that's in our next thing to implement, Databricks now has the native ability to do AES encryption and AES decryption, and you could do both non-deterministic and deterministic encryption and decryption using those functions. So with those new functionalities, you don't have to write these custom UDFs. You could just use those functions and incorporate them. Identify your PII information, pass them through the function, and get them encrypted or decrypted. So which would make this workflow much more simpler. Non-prod data copy tool. So I could go in the end if we still have time, but very briefly, what we do is once we have identified here are your PII columns using table properties. The reason I'm stressing on table properties is, you know, in your table, these 5 columns are first name, last name, and these are PII. What we do is then, in an automated Python function, we browse through, we do describe extended, figure out here are your PII columns, we run them through Faker. We run them through Faker, which means we have now a non-prod data. We have now faked out data, no PII information, but you still have same amount of rows. Your joins would work. Mostly when you copy it to non-prod environment, your systems aren't integrated, you can't join, you don't have same foreign keys, and all those problems. So now you have your production joins, but you are faking out all your PII information, so you can easily copy that to your lower environment and do all your testing in lower environment. So you are creating a prod-like environment, but you are faking out all the PII data. So that's helped our team tremendously because we have been facing this non-prod copy problem a long time. You want to go to the, yeah. So here's more details on how we do non-prod copy tool. We read production data, like I was saying, identify all the non-PII, all the PII data and run them through Faker. You can use Python Faker, you can write your custom Faker, you could just do like convert from one value to another or all the names to John Doe. All that matters is your primary to foreign key relationships are preserved. and then you copy that to a non-prod S3 bucket. Now, once you read the fake data, then then you can't come back into your lower environment and decrypt it because you do not have access to the keys. So all that data is not production, not PII. My name is not Keyuri in lower environment, and it doesn't have my social security number, right? So hope that helps you guys with your data lake setup. Slide back. So that was all we had. We'll open up to questions if you guys have any. We try to preserve time for questions. Thank you.
Thank you. Please raise your hand if you have questions.
So good question. So
how do you manage key rotation?
Yeah, good question. So with Fernet, we use Fernet for non-deterministic encrypt. And with Fernet itself gives like key rotation ability. Using Fernet, you can rotate the keys without having to change our data. Where we do deterministic encryption, which is basically AES, there is no neat way to rotate the keys. So we decrypt the data and re-encrypt with the new key. Right. So I don't know if you. So the question was, how do we pass the key to the authorized user? The way we manage keys is at a cluster level. So if you guys want to Google, and this is in the blog, if you guys want to open up, at Spark config property, there is a config that you can set to access your secrets. Now, whoever has access to that cluster would have access to those secrets. If you do not have access to that secret, then it's just going to give you back the same encrypted data. So you can run UDF without passing any key, and it'll just give you back the same encrypted data. But if you have access to the cluster that has access to decrypt data, then you get the decrypted data.
So I think you have answered my question. I was looking for, how do you store your secrets, particularly how do you access them, and most importantly, do you have one secret or one key for each table? Because you probably are not using data keys for each row. You're probably using one key for maybe entire table or a set of tables or something like that.
Right. So we store secrets in Databricks secrets. That's our secrets control that we use, and then we use it using DB utils. And for decryption, we add that property in Spark config, so people can access it on a SQL layer where they are trying to use the UDF function. And currently we have one key that we use for encrypting all the columns. We don't manage separate keys at separate column level.
Okay, thank you. A follow-up question. Yeah. Have you tried using format preserving encryption?
Say that again?
Format preserving encryption, it's a latest technology, you can say, where SSN will look like SSN, but it will be encrypted. A name will look like a name, but it will be encrypted name.
Right, like a faker.
It's not faker, it's AES encrypted.
Yeah.
Many of the encryption tools like Voltage does it. Yeah. Basically, SSN can be encrypted as a SSN number, but it will not be the original number for sure.
No.
It's reversible, basically.
Yeah, we haven't looked at that yet at this point in time. Thank you for the question, though.
One of the challenges I've found is when you give some people the ability to decrypt things, how do you prevent them from writing the plain text out?
Good question. So and that's something that has bothered me for a long time. I have not slept on it for thinking about it for days, if that makes any sense. So one thing that we do is we disable in our production system, we disable export from notebook. We have most of your users coming in from Databricks notebook and executing SQLs that way. So we disable export to SQL or anything like that in our production, but we can't really stop people from taking screenshot and circulating that data, right? So we are very strict and very thorough with saying who we give out decryption access to. We ask very specific questions, and we make it as hard as we could for people asking for decrypted data, saying, and that's how we try to protect it.
Right. So have you disabled their or all rights to DVFS?
Well, so the way we give out access to our consumers is using the high concurrency cluster. Using that, they can do %sh and then go into files and download it. But our admins can, which really helps with column level encryption. So you could download the files. All you're going to get is chunk data.
Okay. All right. Thank you.
Yeah. Thank you for the question. I think he'll give you the mic.
The read side was interesting, the performance benchmarking. Can you talk a little bit more about how you did that benchmarking?
Yeah, do you want to talk about that, Jenny?
Which one?
The trade-offs. Trade-offs, right?
Okay. What was the question, sorry, again?
The read side was the read side was interesting that it was only effectively the same on the decryption side. So I was just curious if you could talk a little bit more about how you did that benchmarking.
Yeah, so like I said, right, we have this file with 150 million records, and we did column level encryption and without column level encryption. And the data was ingested. We use Databricks, right? And then we run optimize commands and zorder on the table. And when we run a SQL query, basically the consumption layer, we did not find any much noticeable difference. And most of our gold data is also being exported to Power BI. And there also, we haven't seen any performance issues.
Hi. So how do you protect PII that sits in raw files before they get to the Delta tables?
I lost like first middle few
How
words.
do you protect the PII in raw files before they get to the Delta tables?
That's an interesting question. We don't. What we try to do is we do not save any files in plain text. So like if we are archiving files, we PGP encrypt them and then archive. But there is a short amount of time while our process is running, our load is running, where the raw files are in plain text format. What we do is if we are ingesting files, we ingest the files, we delete them, and when we archive them, we actually PGP encrypt them and then archive them. Thank you.
Hello. Like, do you share any encryption functions to the developers? Like once data is ingest and encrypted and created views. So if developer want to write anything on top of it and build highly PI data, so are you building any like function to share with developers so that they can start using and write outputs to data lake?
Right. So we do something very specific. You guys might hear spec prods, right? When we want to do production table updates, we have traditionally been doing spec prods. You pass the value in spec prods and then you update the tables. We have built a similar functionality where developers can go in and do production updates without having actual access to update the jobs. And that job has a way to encrypt the data and then save it to the database. We don't allow developers to manually encrypt it, if that answers your question.
So in the manual, in the sense like they build a process.
Like they cannot do any manual
it's an automated
updates.
process. They can't do it. There is no notebook functionality to manually encrypt it.
Oh, okay. So we have a requirement to do the manual encryption on top of.
But I would say in that case, you would create a PDF, like UDF, you would create a UDF that can use the same function in your job and expose it as a SQL functionality to manually encrypt it.
Okay, thank you.
Any suggestion on the column that is ID and PII?
Oh, awesome example. We have a lot of those. We use social security number as primary keys. We use account number as primary keys. And you obviously need to join on those. So when we were going through solution option comparison, there's basically two ways you could do. You apply encryption, and while joining, you decrypt your data and join. But the drawback to that is you lose performance. You lose time because you're decrypting, joining, re-encrypting. So for those columns, Like we have two ways of identifying our table properties. One is deterministic encrypt, and another one is non-deterministic encrypt. So we let columns like first name, last name, date of birth go through non-deterministic encrypt, so we can do easy key rotations. SSN, account number, we all tag them as a deterministic encrypt, which means using that we can join both columns. So if my social security number is 123, in all the tables, it's converted to the same value after encryption. So then it's then basically joining string to string, right? So all those columns, we have a specific tag and we identify them that way.
Can you quickly elaborate non-deterministic encryption versus deterministic?
So non-deterministic encryption is when you pass through a value, it's going to give out different values. So KUD will always not be it can be XYZ, it can be ABC, it can be RSQ. When you do deterministic encryption, it's always one value. So KUD will always get converted to ABC, no matter how many times you run through, how many tables you run through. If you pass the same key, you are always going to get the same output.
One more question, guys.
How do you guys do to find all those PII data?
So when we started this journey, we were evaluating, should we build AI, should we buy some processes, and what we get data from? We get data from a lot of legacy systems. And we figured out there is no consistency in how these legacy systems named. So we checked that idea and we rely on developers to identify what's PII and PII. Because we think when they are identifying their data, that they are the best people to make that decision if they are PII or not. So when they are creating a table, we have a guidance saying identify all the PII information and add those as table properties. So we don't do any AI or automated way. We purely rely on developers to do that identification.
Okay, guys, we need to get moving. So you can ask your question in the hallway or at the back after the session.
Yeah, I can hang around outside or in the back if you guys have any questions.
Please don't forget to rate this session.
Thank you all for coming.
Thank you all.
And thank you all for encouraging us.
Enjoy the rest of the summit.
Thank you all for coming.